Welcome to Study Guide Forum. In this question, the question says the velocity of sound wave in air is 330 meters per second at 0 degrees Celsius. What will be its velocity if the temperature is increased to 100 degrees Celsius? The next question said, what is the change in velocity of the wave? So now we're going to also use our relation that say that V1 V2 equal to T1 over what T2. In this case we are looking for we are looking for the velocity and also the change in temperature. The first velocity we are given, that the velocity of sound wave in air, which we can call the V1. The V1 is given to be 33 meters per second, and the temperature is the T1 also, which is 0 plus 273. That will give us 273 Kelvin. Alright, the next one we are looking for the temperature T2. The T2 is equal to 100 degree plus 273. That will give us 373 K. So the next one here is to substitute for these values because we don't have the V2 which is the velocity when the temperature increases. So in that case, what we're going to do now is we are going to do the substitution, add up where they supposed to be. We have the V1 to be this, then the V2 is unknown, and the temperature V1 is this one up 273, and the next one is the temperature, the T2, which is 373. So when we open up these brackets by squaring both sides, if we square both sides, what we have here will be 3 squared over V2 squared equal to over 3. So when we multiply through, we will have V 3 squared times 7 all over 2. So what we have here will be equal to 148,790.1. That is for the V square. Then is getting the value of V2 will then give us square root of this 48790.1. That will give us equal to 385.7 meters per second. This is the final velocity. Now the next question says that we should calculate the change in velocity. The change in velocity. So as the temperature changes, the velocity also changes. So the change is that is V2 minus V1 will give us the change in V. So in that case, we have the V2 to be 38 minus 7 minus 33. That will give us 5.7 meters per second. That's the change in velocity. Thank you so much for watching, and we want you to subscribe, like, and share. Thank you so much.